Hello everyone, I am Aman and back with another beautiful question on trees is find lowest common ancestor of a binary search tree. We have already learned, I have already made a video on how to find lowest common ancestor of a normal binary tree. That method is already applicable here, but we can do something better in BST. So I'll start discussing it directly with the new method that works only for BST. So first of all, what is lowest common ancestor? Lowest common ancestor is defined between two nodes P and Q as the lowest node in tree, which is an ancestor to both P and Q. So lowest node, which is ancestor to both P and Q. Let's just say my P node is 7 and Q node is 14. So I want to find the lowest common ancestor between 7 and 14. So if you see the lowest node, which is ancestor to both of them, is 10. So their LCA is what? 10. Let's just try some other example. Let's just try to find LCA of P is equal to 14 and Q is equal to P is equal to, let's just say instead of 14, let me choose 7 and Q is equal to 3. So I have to find the LCA of both of them. Now if you see 10 is an ancestor to both of them. 5 is also an ancestor to both of them, right? But among 10 and 5 is the lower one. So LCA, the lowest common ancestor to both of them is what? The node 5. Now let's just try for, let's just say we are given P is equal to 7 and Q is equal to 9. Let's just try to find LCA in this case. So in this case, the ancestor to both of them are 10, 5. And as per the definition of LCA, we count 9 also as the ancestor of 9. Okay. So in this case, the lowest common ancestor for both of them is what? It is 9 only. Hope the question is clear to you. Now, again, there are different ways to do that. Some of them are directly applicable in a binary tree that I've already explained in the previous video. You can watch that out. In this video, we will discuss only about how we can do it optimally for a BST. I mean, what changes for a BST. So as we know, for a BST, for every node, all the nodes on the left side, on the left subtree are smaller. All the nodes on the right subtree are greater. Okay. So let's just say I try to find lowest common ancestor for 7 and 3. This is what I have to find, 7 and 3. So what I'll do, I'll simply start with my root. I will check where is 7 and 3. Are they both on my left side, on my right side, or in the different directions? So if I see, I will find what? That 7 and 3 both are smaller. So they will be 100% on my left side. So I'll reach to my left. Now I reach this place. What will I see? That one of the values is smaller than me and the other is greater than me. It means this is the point where we are going to diverge. Correct. This is the point. This current node is the point where we are going to diverge. So 100%, this is the LCA. That's how we calculate it. Now, let's see it one more time. Let's just say we are interested in calculating LCA of 14 and maybe I can create a node here. Let's just say I create a node what? 11 here. Now let's try to find the LCA, lowest common ancestor, in a BST for 11 and 14. So I start with 10. What do I see? Both the values are greater than me. So 100% they are on my right side. Now I reach to 15. Now what do I see? Both the values that I'm looking for, 11 and 14, are smaller than me. So 100% they are on my left side. I reach this left place. Now at this point, what do I see? One value is smaller and one value is greater. So 100% this is the point of diversification, and hence this 13 is the lowest common ancestor. Make sense? So that's how it will be. Let's write code for only this part. Then we will see the scenario in which one of the node is LCA of both of them. So let's quickly see. I'm given the node P and Q. I'm given the root node. So what will I do? Simple. If root dot value is less than P and root dot value is less than Q, or let's just say P dot value and Q dot value. So this means what? I am 15 and the LCA that I'm looking for, the nodes for which LCA we are calculating are 20 and something like 25. So I'm smaller than both of them. So 100% both the nodes are on my right side and I'm not the LCA. So we'll go to right side. Simply we'll make a call on the right side and we'll say, hey, right side, return me the lowest common ancestor for both of them. Root dot right, comma P, comma Q. Similarly, if the root is greater than both of them, is greater than P dot val, and then root dot value is greater than Q dot val, it means what? The current root data is greater than both of them. So 100% both the data elements are smaller than me and they should be on the left side. So we'll go to the left side. So I'm saying hey left subtree, return me the LCA of both of them, root dot left, comma P, comma Q. And else means what? That I'm sitting at a point where one of the data node is on the left side, other node is on the right side, right? I am greater than one of them and smaller than one of them. So at this point, I am the LCA, so we'll simply return root. And obviously the base case, which if you want, if you can write, otherwise you don't need to, because you will always be given valid nodes and you will never make the fake call. But let's just write it to be on the safe side. If root double equals to null, return null. Now let's just see how do we cater the scenario when we are looking for the LCA of 7 and 9. So we reach to 10, we find what both the values are smaller. So 100% I'm not the LCA. Let's go to the left side. I will ask my left subtree to tell me LCA. Now I reach to 5, I see 10 and 9, both the values are greater. So 100% LCA is on the other side. Now I reach here. What do I see? If you check the conditions, what will happen? None of these conditions will become true. What are these conditions? That both the data value are smaller than me. Are both the data values smaller than me? Obviously not. One of them is equal. Are both the data values that I'm looking for greater than me? 100% they are not greater. So in this case, what do? We simply return the root element. And this is what we'll do. We'll return 9. So hence this code will work for all the cases. Now coming to time complexity. Every time you're skipping a level, you're either going to the left child or right child. So time complexity becomes order of h. Coming to space also, this 10 will call 5, and I mean every time I'm skipping a height, so in my recursive function, recursive stack space, I can have only order of h number of functions. So space is also order of h. Hope you got it. Thank you so much. See you in the next video.